Good morning. Thanks, Rod, and thanks, Katie King, and thank you to all the organisers for inviting me. I feel very honoured to be in such illustrious company. Now, let's see what we're going to do here. I'll just give you an outline of today's presentation. I'm going to talk about what addiction is, dopamine, which is a neurotransmitter, and its role in addiction and food addiction, some research on food addiction and eating behaviour, the results from animal and human studies on eating behaviour using the addiction model, how we measure food addiction in humans, which foods are most highly addictive and which aren't, some take-home messages and some resources for you to look at on the internet. So what's addiction? Addiction is characterised by three things. Binging on the substance to produce a euphoric effect. So euphoria, lift of mood, feeling good. And it's thought that from binging on the substance, the person develops a tolerance, so they need more and more of it, so they end up over-consuming the substance. The other characteristic is that they develop withdrawal effects. When you take away the substance, they will develop withdrawal effects so that they get a negative affect, they feel really unwell. And then the other criteria for addiction is that the person has a preoccupation with the substance so that they are craving the substance. And the term addiction is often used synonymously with dependence. So that dependence is compulsive and sometimes uncontrollable behaviour occurring at the expense of other activities. So other activities might be work or social relationships or physical and mental health. So substances of abuse activate release of dopamine in a part of the brain called the nucleus accumbens, which produces euphoric effects. And the circuitry, there's no actual evidence that there's a addictive personality. It's actually more biological. My next slide, I'm actually going to explain how that all works. And so I'll talk about dopamine and the implications for food addiction. Dopamine is a neurotransmitter and it's involved in a whole variety of functions, including learning, memory, motivation, fine motor control, pleasure, and neuroendocrine signalling. What that means is communication between the nervous system and the endocrine system, which is all the glands that release hormones. So dopamine is the primary neurotransmitter involved in the mesolimbic reward pathway in the brain. What does that all mean? See that little picture of the brain there? That the red part is the reward system. Dopamine activates that part of the brain, which gives us a sense of pleasure and reward. And dopamine, there are lots of receptors, dopamine receptors throughout the brain, but the ones that we're interested in for the purposes of this talk are D1 and D2 receptors, and they're involved in rewarding and reinforcing natural behaviours, so we repeat and perpetuate them. And so that's thought that we have that system in place so that we will repeat behaviours that perpetuate the species, like sex and feeding, because if we didn't have that reward system in place in our brain, we would have died out eons ago. So dopamine is typically released the first time a person eats a novel or a new food. Dopamine's involved in learning, and so it's thought that the reason that occurs is because we want to focus on that food so that we learn from that experience whether that food is safe to eat or not. And then every time the person eats that food, the release of dopamine diminishes, so that over time that food is encoded in their brain as safe. And so drugs of abuse, though, release dopamine from the nucleus accumbens every time they're consumed, and they activate the reward pathway every time they're consumed. But as I previously said, drugs of abuse develop a tolerance, so the person needs to use more and more of them. So the circuitry is actually in place for food addiction. And so I'll tell you about some of the research that's been done on food addiction to show you that this is real. Nicole Avena, who is a prolific researcher in the food addiction field, used animal models, lab rats, to study the effect of sucrose on behaviour, and she published a paper in 2008 where she described a study where she gave lab rats a limited access to a 10% sugar solution. And what she meant by limited access was that in a 24-hour period, the rats were given 12 hours where they could have access to their normal rat chow as well as this 10% solution. So they had that ad libitum. And what they noticed was that over time, over the course of 21 days, the rats would consume more and more of the sugar solution. They would go to the pipette, they would self-administer this sugar solution. They regarded that as an addiction, but it didn't happen to rats who were only given presentation of the sugar solution occasionally. So remember I said to you about the novelty effect? So what they were doing to confirm what was going on was that the researchers inserted a probe into the rat's brain to measure extracellular dopamine. They anaesthetised the rat, shaved the top of their head, put a probe in, and the probe, and they use what's called microdialysis, and they draw off interstitial fluid to measure extracellular dopamine. And so the rat sort of walks around with this sort of funny-looking probe out of their head, and when they want to measure interstitial fluid, they'll hook it up to very fine tubes to measure that, so that they can tell how much dopamine is being released when the rat is eating either sugar or rat chow. And when they administered an opiate agonist to these rats, in which this case was naloxone, and that actually blocks the dopamine receptor, the rats experienced withdrawal effects. They showed the behavioural attributes of a rat that was in distress. And they were also able, through this probe, through this microdialysis, to measure a substance called acetylcholine, which is released when a person or a rat goes through withdrawal effects. So Nicole Avena and her colleagues have done further studies on rats to see what they do when they eat food like junk food and what happens to them. And so what she did was she had a group of rats, and she randomised them to two groups, and she placed one group on a cafeteria-style diet, which was basically a junk food diet. So any kind of food that you went into a service station, and any food in a service station is basically junk food. And so that's what the rats were given. They weren't given any rat chow, just this cafeteria-style diet, and the purpose was to induce obesity. Oh, I should mention that some of the junk food was higher in carbohydrate and some of it was higher in fat, but the rats actually preferred the higher carbohydrate food, hence the weight gain. And the second group of rats were fed their standard rat chow and they maintained their normal weight. The obese rats developed brain changes. And so, of course, they had the probe in their brain to measure extracellular dopamine. And what was funny was they actually showed lower extracellular dopamine. But the obese rats only released dopamine in response to the cafeteria-style diet, but not the standard rat chow. And this is thought to be one of the reasons why some people develop addictions, is because they're not releasing as much dopamine as other people who aren't prone to addiction. And there's a whole lot of research about why that might happen. And frequently you see that in people who have experienced early childhood trauma, that they are at higher risk for developing addiction later in life. And it's thought that they've undergone brain changes, maybe through epigenetics, so that they don't release as much dopamine. So what they found, the researchers concluded, was that there was a link between food preference and central dopamine, and maybe that explains why some people will go to certain foods because they are comforting when they're distressed. So they concluded also that a dopamine deficit is implicated in overeating and obesity. So there's been other findings from other animal studies, and there's been overlap seen in animals between sugar and drugs of abuse. So animals have shown similar behaviours for drugs of abuse. And, remember, self-administered binging, tolerance and withdrawal, as with sugar. So they showed the same chemical changes, that increase in dopamine for sucrose as for drugs of abuse. I should mention sucrose is table sugar, so it's 50% glucose, 50% fructose. You often see in the media, you'll see headlines like, sugar 8 times more addictive than cocaine. There's actually no evidence for that. The different amounts of dopamine released are actually dependent on what the drug is, or what the dose was, or how much sucrose was in the solution. So you can't actually say that sugar is X number of times more addictive than another drug, or vice versa. So what they found from the research is that highly palatable, high sugar foods hijack the brain reward system so that they may alter reward and lead to overconsumption. And in another study, rats that were fed this, they're actually fed M&Ms. And what they did was they would cross an electrified barrier to get to the M&Ms. And they've also shown that the greater the variety of food, regardless of hunger, the more is eaten. And you see that in a buffet-style presentation of food, that people will eat more in that situation. And it's probably because of the novelty effect and the increase in dopamine. And so it's also been shown in addiction studies that there is what's called a cross-sensitisation, so that if a person is dependent on one substance, they're more likely to develop a dependence on another substance. And you frequently see, nicotine and alcohol going together. I haven't come across too many alcoholics that aren't dependent on nicotine as well. And when alcoholics abstain from alcohol, they often pick up another substance, and sugar is a frequent substance that they will substitute for alcohol. So it's proposed that, is sugar a gateway drug? So can we measure addiction-like responses to food without putting a needle in our brain? Yes, no needles required. Ashley Gearhart and her colleagues developed the Yale Food Addiction Scale. And she published that research in 2009, and this is a 25-item self-report scale. And we call it the Yfas, and the Yfas was adapted from the substance abuse dependence criteria in the DSM. The DSM is the Diagnostic and Statistical Manual of Mental Disorders, and that's published by the American Psychiatric Association. It's published every sort of 5 to 8 years, and we're up to number 5 now, so we've got the DSM-5, and so they have a set of criteria for substance dependence, and the Yfas was adapted from that. And so the Yfas measures addiction-like responses to food, and the higher scores on Yfas are seen in binge eating disorder, obesity, and people with increased impulsivity and emotional reactivity. But food addiction can also be seen in slim, normal weight and overweight individuals, and I think that's very much about how insulin sensitive they are, which Marty Kendall referred to in his talk. So not just because you're addicted to food and can't stop eating sugar doesn't mean that you're going to be obese. So using the Yfas with FMRI. What's FMRI? FMRI is functional magnetic resonance imaging. And the Yfas has been validated by FMRI. And in behavioural science, it doesn't get any better than that. What does that all mean? Behavioural science is accused of being a soft science. We rely on what people tell us, self-report, or we rely on our observations to make diagnoses. There's no blood tests, there's no x-rays, there's no tissue biopsies. We're relying on information that's open to a huge amount of error. And so what Ashley Gearhart and her colleagues did was that they developed a study which showed that the Yfas is a valid measure for addiction. And so what they did was that they got a group of participants and they administered the Yfas, and they identified who scored highly on this measure. And then they put them in the scanner, and an FMRI measures blood flow in the brain. That's what it does. And so what they were looking for was where was the blood flow going. And so they showed the participants two things, and what they were measuring was anticipation and reward. And they had a chocolate milkshake, picture of a chocolate milkshake, and then they had a drink. And the drink was not water, because water's got a taste, but they actually developed a solution that was saliva-like. It was sort of like, it sounds disgusting, but that's what it was. Anyway, they put them in the MRI scanner, and when they showed everyone the picture of the chocolate milkshake, they scanned their brain to see what would happen, and then they showed them like what looked like a glass of water, scanned their brain, and then they actually gave them the chocolate milkshake, scanned their brain, and they gave them this saliva solution. and what happened? What happened was that the highly palatable food, i.e. the chocolate milkshake, released dopamine. But it only, and what they found was that the parts of the brain that were activated were the parts of the brain that are known to be associated with cravings. And it only happened in the people who scored highly on the Yfas. So it's assumed that craving drives overconsumption, because the other interesting part of the study was that when the high scorers on the Yfas received their reward, which was to drink the chocolate milkshake, there wasn't any activity going on in the craving part of their brain. Again, it's probably assumed that, well, they've already got their reward, so there's no need to be craving any further because they've got it. So there's also been some studies in humans to study food addiction. And Nicole Avena, Ashley Gearhart and Schulte researched the foods that were most addictive. And what happened was, again, they got a group of participants and they all completed the Yfas. And they were shown a list of 35 foods ranging in various ways, in differences in glycemic load, fat content, whether they were processed or unprocessed foods. And the participants were asked to rate each food on a Likert scale, and a Likert scale is just 1 to 7, a range of scoring. 1 was how the food was unproblematic for them, and 7 was very problematic. And problematic meant they had difficulty cutting down the consumption of that food, or they were losing control and overeating that food. And then the researchers ranked all the foods in order of most problematic to least problematic. And what the study showed was that not all foods are associated with addictive-like eating behaviour. The 5 most problematic foods, and this is not surprising: pizza, chocolate, cookies, well, biscuits to us, ice cream and chips, that's crisps. And so they were the most difficult to stop eating. And the least problematic were cucumber, plain brown rice, carrots and beans. And that's not green beans, that's like beans as in, white beans and lentils, that kind of, those sort of beans. And broccoli. So people could easily stop eating those foods, but the other ones they couldn't. And so the conclusions that these researchers drew were that highly processed food may share some of the same properties as drugs of abuse, because the foods that were most problematic also had a high glycemic load. And you learnt about glycemic index from Marty's talk, and glycemic load is about the quantity of food. So it takes into account, it's a calculation that takes into account the glycemic index and the quantity, and you come up with a score which is the glycemic load. And food that has a high glycemic load has a high dose of glucose, and it's giving the brain a big hit. So there's a rapid rate of absorption of sugar in the brain. And so, as I just said, foods with a high glycemic load were especially problematic for people with a food addiction who had high scores on the Yfas because of this high rate of glucose and the rate of the rate and the dose of glucose. What was not associated with food addiction were unprocessed food. So unprocessed food was not a problem for anyone. So some take-home messages for everyone. Overeating is not about lack of willpower or motivation. There's a real biological basis to overeating highly palatable food. It's physiological, it's not psychological. So eating highly palatable food mindfully to control intake just won't work if you have a food addiction. It's possible to develop a food addiction to highly palatable food and exclude healthy food. So something I think I didn't mention in one of those earlier studies is that when the cafeteria-style rats, the rats that were fed on the cafeteria-style diet were offered normal rat chow, didn't want to know. How often do you see that in real life? So, they also showed that food addiction or overconsumption doesn't occur when the highly palatable food, i.e. food that's got lots of sugar in it, is consumed only occasionally, so for special occasions or treats or something like that. It's no big deal, you're fine. But consumed on a daily basis, it can become a problem. So, if a person has what they think is a food addiction and they want to stop that, they've got to apply the same treatment as for substances of abuse, and that is complete abstinence. You've got to abstain from the food that's problematic and avoid coming into contact with it to reduce your cravings and achieve some control over that behaviour. Of course, you've got to eat though. I want to make a special comment about bariatric surgery patients, and that's really important that they avoid highly palatable processed food because they can risk regaining all the weight that they've lost. I see quite a lot of bariatric surgery patients for pre-op assessments and also post-op follow-up and support, and they come from a number of different surgeons, or they just find their way to me. And since I started measuring food addiction in those clients, I would estimate or guesstimate probably about a third would meet the criteria for food addiction on the Yfas. I'm disappointed/appalled that those patients are given preoperatively, or not given, recommended preoperatively and postoperatively meal replacements that are very high in sugar, especially for people who have a food addiction. Bariatric surgery is a perfect opportunity to almost go through a detox, to get that out of your diet and to reset things so you can start eating normal, healthy, real food. But if they're given meal replacements that are high in sugar, it sort of defeats the purpose. I see a lot of people who've regained all the weight they've lost, or they haven't lost very much, and they're still eating lots of processed food, which has been recommended to them in smaller amounts by way of meal replacements or low-fat yogurt or, Anyway, so food addiction and overconsumption doesn't occur when you're eating real food. It only occurs when people are eating excess sugar and refined carbohydrates. So if you want to achieve and maintain a healthy weight, and you've got to learn to cook, and you've just got to eat real food. That's the take-home message. Okay? So, a couple more things. Some resources. There's a fantastic animation on YouTube which was developed by Nicole Avena, and it's on TED-Ed, and it's called How Does Sugar Affect the Brain? It's a 5-minute animation. It's brilliant. So go and look for that. You can go and look at her website. All the studies that I've referred to, you can download the PDFs, or you can write to her and she will send you a copy of those studies. You could also find Ashley Gearhart. She's at the University of Michigan, and you can find her on the internet, and you can find a list of her references of papers that she's published, and you can access those. And finally, if you're sort of interested in the psychological stuff and what increases a person's risk of developing addictions, go onto YouTube and search Dr. Gabor Mate. He's a Canadian doctor and addiction specialist, and his videos are quite exceptional. So that's me. If you want to contact me, just Google me, you'll find me on the internet. Thank you for being such a great audience. Thank you.